Hello. So today we'll start with the basics of NLP. Like even the first conversation we must hold is what is NLP. Okay? So what is NLP? NLP is basically nothing but natural language processing. So we are going to talk about natural language processing. So how do we? The main thing we are going to deal with is how can we process any language. Let's say I am a cat, right? So how do we process this language, what is language, everything will go in much detail, and today is going to be a very introductory class, not much in detail. So whenever we are working with any NLP task, for example, how do we go about it? Okay, the first thing that you do is you get the data, right? So get the data, you get a data. The second thing you must do is clean the data. What is the third thing? Then you process the data, as in like we will do these today. Process the data means, like for example, removing unnecessary words, for example. Then we do something called feature engineering. What do we mean by feature engineering? So if there is something which is more important, right, we give that more importance, that feature to be more important rather than the other features. Next, we actually make the model, whatever the model is, and after the model is done, we train the model on the data. Finally, we do a evaluation of the model. Did we do good or did we do bad? And finally, if this thing is correct, we deploy the model. So this is the main things that are covered in NLP. Like this is one life, like you can say this is the life cycle of a NLP project, NLP task or anything. Okay. So today we are mostly going to be dealing with these three. Like in short, even for the next lectures, it's just going to be these three. And yeah. So now what can be your task in NLP? So the first thing that can be a task is something called sentiment analysis. What is sentiment analysis? So let's say if I say I am happy, is this a positive sentence or a negative sentence, right? So this is a positive sentence. So you analyze this sentence and you tell it sentiment. That is one aspect of NLP. Next we have something called POS tagging. What is POS tagging, you might ask? Parts of speech tagging, as simple as that. So for example, let's say dogs are nice. So this is a noun, this is a verb. I think nice is also a noun, right? So like this tagging of POS, the part of speech is important. Because why do we need that? Because in some case, let's say will can be a verb, will can also be a noun, somebody's name is will. So POS tagging is important as well. And next we go to something called NER, or named entity recognition. So let's say if I have an example, like let's say I bought an apple, and let's say I said I bought an Apple phone. So if you notice, so this is a fruit and this is a company, the same word. So this entity, this is a company entity and this is a fruit entity. So this recognition, this task is called NER. Okay. And next task which is mostly used is machine translation. So if you have sentences like my name is, let's say, what do you call it, my name is, give me any name like Rahul, for example. Okay, so I don't know Hindi that much. I think it should be like Mera Naam Rahul. How do we write this? Like this, no? Rahul. I don't know how to like this. I have no idea how to write Hindi. Okay, might be this is the correct Hindi. So this translation or English to Hindi. Okay, so Mera naam Rahul hai, for example. This is called machine translation. You can also have some summarization tasks. So what is summarization task? Let's say if you have like 100 lines, you summarize that in 3 lines. That's a task. Okay. Question answer tasks, like what is 2 plus 2? It gives the answer 4, right? So these are some tasks, and these are the main tasks that are there. Okay. And so we discussed what is the life cycle of an NLP task, and like what can be some examples of an. There are many, but these are some of them which I have mentioned. And now we want to dissect a sentence. Okay, how do we dissect a sentence, or like words in general? Like how do we dissect them? Okay, so a word, for example, let's say taking. This word is actually from a made from the word take, for example, right? So these things are called morphemes. Morphemes. So morphemes are like the building blocks of words. So take is a morpheme, from that we get taking. Okay. So of course take comes from take itself, right? So that is called a free morpheme. And like in this case, this is called a bound morpheme. Okay, because it's using the word in with it. Okay, so the main thing, and I think you everybody knows what a part of speech is. I'm not going to go in detail of this. Part of speech is what? Noun, verb, adjective, adverb, and many more. Okay, so so like now we are going to talk about something called a stemmer. Stemming or stemmer, whatever you call it, stemming. So what stemming does is it breaks the words into meaningful stuff. Like for example, run, ran, running. Everything has the same concept, right? These all of them have the same concept. So you map all of them to the same word. Let's say a run, for example. Okay. So even like the word, let's say lens, that becomes len. Okay. So this is how like basic stemming kind of works. So there are many kinds of ways you can do a stemming. You have in we are going to be using two libraries. One is called NLTK. There is another called Spacey. Okay, we are going to be using NLTK. So in NLTK we have something called a Porter stemmer. Okay, so these are algorithms, okay, which you can learn in detail. We'll not go in much detail. So let's try to run this. So first we'll import the libraries and everything. You can see what the libraries are and everything. So the first thing that we're going to do is get the Porter stemmer running. So we'll name it like, let's say Porter equal to Porter. Let that thing get running first. Porter stemmer. So this is the command. Okay. Once you have done, you give the tokens. For example, let's say tokens is equal to running. What can you give me some more examples, like happily, for example, happily, better. I have no idea. Like that can be one thing. Like say organization. Okay, so these are my tokens. So you can see the tokens. These are my tokens. Now I will do Porter stemmer. So what I will do is for t in tokens. For t in tokens, you must run the Porter stemmer. How do you run that? So you write, for example, let's say print f. Let me print the token first. So this is the token. And from the token, we are getting porter.stem.t. I think this was the syntax. If I'm wrong, I will fix it later. But yeah, I feel this is the yeah. So run becomes, let me give a gap, I guess that would be better. Yeah, running becomes run, happily becomes happy lie, better is better, organization becomes organ. Okay, so in some cases it does not make sense, is what I mean. Okay, so this is how like stemming kind of works. And so So now we are talking about a very similar thing called lemmatization. Lemmatization. Okay. So these are like algorithms where you get the word and you break them down like earlier only, but into lemmas. Lemmas are what? Lemmas are basically the semantic form. Okay. So semantic form means it will retain a meaningful word. Okay. So this will have a meaningful word. This is a very important difference between stemming and lemmatization. Stemming does not can give a nonsense word, as you saw. Happy lie is not a English word, right? It can give you a nonsense word. That's a Latin word. But lemmatization will always give you a logical word. So lemmatization also, let's actually try to do it. So we have a very famous lemmatizing algorithm called wordnet. So let me name it lemmatizer is equal to wordnet lemmatizer. So this is my lemmatizer that is ready, and I think we'll be using the same let's say, let us use the same tokens we had, right? So so for example, let's say 40 in tokens, print. Let me just copy this now, that would be better. So instead of porter.stem, you will use lemmatizer dot, I think it was lemmatize, that was the, might be wrong, I have no idea, let me check. No, it's not wrong. So yeah, I did not break them down to anything. Like, let's say instead of blah blah, let me add one sentence. I think, let's say, let me do mm, t dot append run. Let me do let's say history, and let's say I'll add history. Why not? Why not? Why not? Is it? Oh, this is not t. Sorry, it's tokens. Tokens dot append history, and I'll do a tokens dot append historical. Okay, I think that will map to the same. No, it does not map to anything. So I think, yeah, I am not getting a good example to show, to be honest. uh, like can studies be a case? Studies, where it actually does it. Studies, yeah, studies is to study. Okay, I got found a good example. Studies maps to study. Or maybe like does the plural form work? I have no idea. Let's check it out. I'm also figuring out with you. Let's say geese. Yeah, geese does to goose. So if you see, it retains the context more accurately than stemmer, because it actually makes sense at the end of the day. Now the final thing that we are going to do is something very simple called stopwords. What is stopwords? So in stopwords, we kind of are the words that are very not contributing that much to the context. Let's say dogs are nice, right? So is are contributing that much? So if I make it dogs nice, it actually means the same thing but with less number of words. So we will try to remove some of these stop words. So how do we do it? First, we have to get the stop words. Okay, so get the stop words, we, let's say, name it stop w is equal to I think the command was like stopword dot words, stopword dot words, and we are doing English, right? We'll do English, not end, English stopwords, and we'll get the set of it because we want unique characters, right? So this is okay. So let me just see the top 5 maybe, like yeah, it is not subscriptable though, like for I in range of 5. Let me in range of 5, let's print stopword 5 I. Oh, it's not subscriptable, so I'll just do stop words, bro. Let me just see the stop words, all of them maybe. Yeah, so yeah, these are the stop words, for example, right? So what can I do? So let's say my sentence is, um, what was my sentence? I would say, um, dogs are nice. Okay, so or we can also do this sends equal to, let's say, dogs are nice, and then you split it, so it becomes words is equal to sends dot split whenever there's a gap. So if you see this word, you will see, you will get the words, right? So dogs are nice are there. So how do I remove the stop words? So simply we will print all the words that are not in the stop words. So let's say updated words is equal to I for I not in stop words maybe. Okay, I mean that is one. Wait, let me. How can I do this? Yeah. So for I in the words. So what will this do? This will just copy it, right? But now we have to check that it is not in the stop words. Okay, and so what we'll do is that if let's say I dot lower not in stop words. See, we removed R, so it becomes dogs nice. Okay, so this is how stop words work. So today we did some part of the pre-processing of data. We will continue with tokenization the next day. So that's it from for today. See you the next day.